Very good afternoon to everyone. So myself are Nareshkumar, full-time research scholar, Department of Networking and Communication from SRM Institute of Science and Technology, Kotangalottu, Tamil Nadu, Chennai. So my project research topic is a novel hybrid smooth oversampling approach for balancing data class in distribution on social media text. So abstract of my project. So basically my project is based upon the social media text, so which is Twitter, Facebook, and all the data is common. But in this project I used some online dataset from the Kaggle. So in that we have determined the depression related words. So depression related symptoms we are identifying that could be work for the earlier detection of crucial avoidance of health conditions. So I have taken depression. So depression is a mental health condition problems. It will be directly related to the human affection and emotional thinking, behavior, all the aspects. So here my thing in my project, I am going to address the problem, challenging problem is data imbalancing issue. So it will be often like lead to be bias. So in many cases we use the traditional machine learning algorithm in the majority classes as well as minority classes. So I'm giving the approaches hybrid BI-LSTM with the smooth techniques. So we have using to detect the depression detection after applying smooth technique. So in that, smooth is playing a main role. The smooth is another one. It's called a oversampling technique. The smooth is synthetic minority oversampling technique. So this is we apply generating synthetic data to the dataset for the class distribution. After the smooth, we apply the Kalman smooth also. The Kalman smooth is nothing. It's a filtering technique to apply before smooth application. So it will helpful for the reducing the noise from the synthetic sample. So basically it improve the quality of the final data set, and it will give the data accuracy results, and it will reduce the size of the overall data set, and it will improve the accuracy and when compared to the previous methods baseline models, as well as the balancing and imbalancing data. Finally we apply in healthcare application, we achieve like a depression detection through the social media text. So introduction, let's start from the again the depression is the most mental disorder health condition problem. So it is a disease related one. We usually it will be often lead to suicide also. So the crucially it will be identify and synthetic the body of the research on the depression symptom identification on the social media utilizing the user input. So in social media they have shared all the information, their mindset and affections, their thoughts, everything throughout the mostly they share in the social media text. Here we are going to take that social media text only, we are going to apply in our application. So the mental depression is another global health problem, like it significantly to the each and every individuals, and it responsible to the number of dead in every year. So the WHO, World Health Organization, also determined like approximately 284 billion people affected for the anxiety in the report survey by 2017, and 46 million people are affected by bipolar disorder, and 264 millions are affected from the direct depression, and schizophrenia affected people are 20 million people, and some 60 million people are affected in the eating disorder things. So, so finally, we are taking this issue as a scientifically. We taken investigation by using the machine learning algorithm to identify the unwanted noise on the internet. Like this is happening. We have early detection stage in the using this social and media data. So we have taken this type of challenges to apply uh, by using the machine learning algorithm and statistical topical modeling and feature engineering to detect the social media text like related to Twitter tweet from them. So for that, we used machine learning as a technique, RNN algorithm, deep learning technique. The RNN algorithm we used particularly LSTM. So it will be applied for the sequential data text. So in my project also we are creating the strategy that we are going to identify the category of returned work that will be display the text over the symptoms of depression. So we achieve using the undersampling and oversampling technique to improve the data presentation. That should be helpful for the classifications of depressions, everything. So the class imbalancing is a problem that scenario like a disease diagnosis direction. Why? Because we have a less number of possibility cases, major classes and minor classes. Major classes will be a lot of options. So for example, depression related text and non-depression related text. I mean, depression related text we have a larger number of, and non-depression related we less than count. When we given for the machine learning we trained, so the majority will be high, means the system will get some bias, so that we used class distribution concept. So next, we have discussed some of the literature review. From that literature review, we have identified some of research gaps are there in the social media text and related to the my application. So we have identified that language detection and noise filtering. So it is the noise related to the irrelevant content of online. So we apply some statistical method for that particular modeling, feature engineering, everything. So we focused content related, health related analysis. This is one research gap, and another one is text categorization. So it is related to the algorithm that RNN algorithm we used, means it is specially handled that sequential data. So when we apply the category of text, the RNN algorithm will use to identify the detect the pattern that linguistics make. It will be return related to the text. So another results gaps are also that resampling of a class imbalancing. It is a major challenge when we deal with the imbalancing data. Depression related content is likely less sequence when compared to online content. So other things are also the challenging issue in class imbalancing is related to the domain. So the domain is disease diagnosis, fraud detection, and number of positive cases, number of negative cases. So the number of negative cases. So in that disease identification also false identification in the data set. So there is also the challenge. Ultimately, the final this project is strategy. We created depression related content. So in data imbalance. So we chosen like a data imbalancing is a major research gap in this domain. I also chosen that we will give some problem statement summary here. That problem statement basically the early detection of depression throughout the social media text that analyze the challenges class imbalancing. So that depression content is significantly playing a main role to identify, classify like a depression or not. So it will helpful for the health outcome, so health application. So the data imbalancing is lead by bias in the machine learning models to trouble that accuracy to identify the depression symptoms with the effective. So this is a problem statement I have created. So the our contribution here, we introduce our BI-LSTM with the SMOTE technique for addressing this data imbalancing as well as social media classification, like depression and non-depression classification. So we have two steps. First one is we apply uh, BI-LSTM. Before that BI-LSTM, we used starting pre-processing technique, everything, and we used a feature extraction step. We used bow and TF. IDF is used for the feature extraction. Bow is a back of word, and the TF IDF is a term frequency and inverse document frequency used for the feature extraction techniques. in the balanced dataset as well as the imbalancing dataset. Here the balancing and imbalancing is initially we taken our dataset. Initially we feature extraction everything done. When we apply the SMOTE application, SMOTE is a synthetic majority, like a minor oversampling technique. After applying, the dataset will be getting balanced. So generally we said unbalancing and balancing dataset. So final our output will be balanced. That means resampled SMOTE applied dataset will be our result. So second step after pre-extraction technique, we apply SMOTE technique in a two phases. SMOTE is a synthetic minority oversampling and SMOTE link, and synthetic minority sampling oversampling and edited nearest neighbor technique. Both will be applied to in our data distribution. After that it will be create a regenerated data set. Okay, so after that we apply Kalman-synthetic method. It is basically to remove the noise in the final data set. So we can apply that in your original data set also and synthetic generated data set also. The system is finally getting a result with good results when category based. Okay, so this is our methodology black diagram. So initially we will explain from the dataset, training dataset. So first initially we have start with the pre-processing work. The pre-processing is we removing like stamping, lamination, everything basic operations will be carried out in the pre-processing techniques. So after pre-processing we apply that into extraction values. That extraction value centered to the particular bow and TF for the bad embedding. It will be feature extraction step. So the after feature extraction we apply SMOTE Tomek and SMOTE ENN. So both will be here treated as a hybrid approach framework. So the both hybrid approach framework will give the synthetic generated balanced data set. Then we apply Kalman-synthetic algorithm for the noise clearance from the data set. When we created the smooth technique, so it will be automatically creating the unwanted noise data set. So we remove that purpose. We used applying Kalman-synthetic technique. It is a filtering technique. It is a removing noise from the internet data set. So finally we reshaped and the classification purpose we sent a BI-LSTM deep learning algorithm. So BI-LSTM is a long short-term memory. It's an algorithm. It's a sequential data deep learning algorithm. It will be giving like our training dataset as well as testing dataset. So after the training dataset and the testing everything, so the model will be get well trained. So finally the output layer will be giving a classification of depression as well as non-depression data. So the performance metrics to check the model efficient or not by using the accuracy, loss and precision and reference score. By using this we used 50 epochs with operations and the training and testing prediction. So we will get some result. So before that dataset discussion, the dataset will be generally work with the labeled data. So the flow of the work with the data. So we divided into data training and data testing. So data training and testing. Training data will be apply to the next level of training and turning, like next to validation. So after the validation, testing will comes. The testing data will be get for the validation or a prediction. So prediction and the classification. The classification is different. Prediction is testing purpose. We check with our data with the thing. So data set, when we talk about the data set, so initially we have two data sets. Raw data set have imbalanced data set. Fine. So the imbalanced data set having the mixture of things. Okay, so the balanced data set we have a difference, depressive and non-depressive with our balanced. That imbalance in data set minority majority. So minority and majority classes, once 70% of majority and 30% of minority. So like that it have that difference. So we apply SMOTE. We are going for the SMOTE technique to balance data set. So when balanced data, it is very much helpful for the model machine learning algorithm to work with efficient manner. So this is the result we have obtained from our proposed method hybrid BI-LSTM with the SMOTE, TOMC and ENN. So and also in this table we compare with the previous comparison with the SVM classifier ROS and LCL and SMOTE ENN only SMOTE TOMC. So in that we used so that smart TOMC and ENN both will be used, and the accuracy we obtained by 93, 92, 91, 93. So 93 accuracy, precision 92, and recall 91, and FN score is 93. So when compared to previous baseline models, I get some better result in this model. So the result discussion we used like previous table we have discussed now, that everything will be discussed. So finally the BI-LSTM hybrid BLI approach is getting more successful. So the suggested model demonstrate the performance all over. It is the most detecting depression. It is related to the healthcare application. So the accuracy and the loss we obtain for the imbalancing dataset by using this TOMC and ENN. So we operated for the 50 epochs training accuracy we conducted, and loss also we conducted. And this is a ROC curve when compared to previous models, ISPM and all few models I have taken for comparison of ROC. So area under curve, it is to helpful to identify the model fitness. So model fitness, it's related to up to 1 is the best model. So my model attained 8.5. So 85% model fitness. So it is calculated by two positive rates and a false positive rate. So I have given comparison. So finally my model have comparisonly high with accuracy. Here I have taken the accuracy and precision recall FN score to comparison with the baseline models. So the conclusion when the comparison with the conclusion with the topic. So I used to address the symptoms of depression to research and ultimately smooth TOMC and ENN oversampling techniques. And for classification, best to work with the BI-LSTM. It is a sequential learning data. So the event distribution values throughout the data set. It will the research is combined with the SMOTE techniques, oversampling techniques, and some deep learning techniques. So the deep learning techniques will work with the classification part, as well as this data distribution taking care of SMOTE. So finally it will be hybrid approach of SMOTE, TOMC and ENN give the better result with using of sequential data network of LSTM, BI-LSTM. So the final result of a model when compared to baseline models, the identification of symptom of depression independently distributed data. So it will be helpful for the efficiently identify the early depression stage in the healthcare applications. So my future work will be a hybrid approach to address the depression detection in a undersampling and oversampling. So here we applied only oversampling technique. So we apply in a future undersampling and both the techniques, and also with SPM classifier. So SPM classifier will give some results, better results. So I have taken for the both under sampling and oversampling. So we can take as a GRU for the future results, future work for the balancing data set. So these are the reference papers we have referred. Thank you for your time.